Hi, another quick video here. We're talking about today chapter 2.1, the quotient rule, also known as the definition of the derivative. It's how we can find a derivative of a function or a slope of a function with the help of the difference quotient. So here we go. Some things to do is the problem says given that f of x is x squared plus x minus 1, use the difference quotient to find the slope of the function, and then eventually we're going to write the tangent line or the equation of the tangent line for a given point on that curve. So first thing we're going to do is substitute x plus h everywhere we see that there's an x in our original function. Secondly, we'll subtract an original function. We substitute that into the equation. And then step 3 is we'll expand or simplify the expression until we have the slope of the line. So here we go. We take the limit as h goes to 0 of our function. So we're going to look at our function now. So our function was x squared plus x, let's come over here, x minus 1. So wherever we see an x, we want to replace that with the x plus h. So we'll place that with an x plus h, that x with an x plus h, and so forth. And then we'll subtract it. So what I've done here is I've gone ahead and substituted this information in. So here's that x plus h that we saw originally. Here's another x plus h. This one's squared. This was where our x squared was. That was where our x was. And then there's our minus 1. And then we have to subtract the function itself. So we subtract, big minus sign here, to make sure, since we're involving a polynomial, that we have to distribute that negative throughout. And so when we do that, this is where we are. And that is all over h. Okay? So when we take the expanded, when we expand it, we get x squared plus 2xh plus h squared. And then there comes x plus h, that's from there, x plus h, minus 1, there's our minus 1. And then we've distributed this negative, so we get negative x squared minus x plus 1. All right? When we go down further, we'll notice that some things go away. For instance, let's see. There's a negative 1 and there's a positive 1. So those two can definitely go away. They'll simplify out. There's a negative x squared and a positive x squared. Those will simplify. Then we have an x and a negative x, and so those will simplify, leaving us 2xh plus h squared plus h all over h. We come down here, we notice that it's 2xh plus h squared plus h. We can rewrite that as 2xh over h plus h squared plus h over h. Now the nice thing there is, again, we can simplify. That h goes away with that h. An h there goes away with an h there, so we're left with an h up top. And then we're left with h over h is just 1, so we're left with 2x plus h plus 1. Now when we apply the limit as h goes to 0, we'll notice that this h actually goes to 0, and we're finally left with a slope, or an equation of the slope of the line, which is 2x plus 1. And that's what we wanted. Now what we can do is, with that information, we can go anywhere on the curve, and we can find the slope of that particular line. All right. So now it says, next part of the question says, let's get up there a little bit, write the equation to the tangent line at 2, 5. So we have our y equals mx plus b here, and we know that our m is our slope, which is 2x plus 1. And we want to find it. They tell us to find it at x equal 2 and y equal 5. So all we have to do is substitute that information into our y equals mx plus b formula and simply solve it. So if I do m of 2, right, our slope at the x value of 2, 2 times 2 is 4, 4 plus 1 is 5. Then we put in a y value of 5. We substitute that over here for y is 5, and y equals mx plus b. M we found was 5. Then we have an x value of 2, and plus our b value, which we don't know. That's what we're trying to find out. 5 is equal to 10 plus b. We subtract 10 from both sides, and we find that 5 is equal to b. And now we can see that y is equal to 5x minus 5. All right, that is the difference quotient. Happy to help. Hope if you have any questions, I urge you to pause the video, go back and retry it yourself, and see what you can come up with. All right, thanks.